This is part 2 of example 1. Now that we have figured out the vector components that are acting on our skier, we can begin to solve the problem. So first, as always, let's start collecting the data, what's given to us. So here we know that this is example question A. We need to find the acceleration, but let's collect our data. So we know that mass of the skier is 60 kilograms, and that's pretty much it. But we also know this. We also know that there's a force of gravity acting on it, and the acceleration due to gravity, we know it to be 9.8 meters per second square. Right, and what we're looking for is the acceleration. So let's put that as a question mark. Now, apart from the angle that is given to us, we also can figure out what the force of gravity is, since we know it's acting downwards. And so let's figure out the force of gravity first. We know that the force of gravity equals to mass times acceleration due to gravity. So the mass of the skier is 60 kilograms. I will not write down the units, times 9.8, and this gives us, so you plug it in your calculator, alright, and this gives us, so it's 588 newtons. Alright, so let's write it down with the units here. 588 newtons. Good. So we know that this force right here, let me use a different color. We know that this over here is 588 newtons for the force of gravity, right? So now what we have is basically a triangle. We know what and it's a right angle triangle. We know what in this case the hypotenuse is, and we're given the angle. So we need to find out the parallel force. Sorry, that wasn't on the screen again. So we know what the length of the hypotenuse is, or in this case the magnitude, the force, and we have an angle, right? So we can use trigonometry to figure out the parallel force, because as we said before, this parallel force will be parallel to the slope and also the same as this force, right? Now, since part A is asking us for the acceleration and to ignore the friction, I don't know if you can see the friction there, they're asking us to ignore the friction, right? Then we know that the force applied here is essentially going to be our net force. So I'm just going to call it force applied. But for part A, we know that the applied force is going to be our net force, since we are ignoring the force of friction. Okay, so now we have this component, right? The force of gravity, which we figured out, it was 588, and we need to find the parallel force. So how do we do that? Well, the parallel force, right, would be opposite to the angle, and so opposite over hypotenuse. So we can use sine. We can use sine in this case. So let's do this. We use sine 25 degrees is equal to opposite over hypotenuse. So opposite would be the parallel force over hypotenuse, which is the force of gravity here. And well, I'm just going to go ahead and write down the units. So now we figure out the parallel force is going to be equal to, right, this is dividing, it goes multiplying on the other side, and so you multiply these two, you grab a calculator, and it gives us, so 588 times, we have sine 25, and that gives us 248.5. okay? So we put it here, 248.5 newtons. So great, so we figure out what the applied force is, and let's just label our triangle, right? 248.5 newtons. Okay, now they're asking for the acceleration. Well, we have the mass, we have this, and we can use this formula. Let me just continue with this problem right below over here. we have this formula, which is, let me just put some limits here, which is, in this case, we know that the force applied is equal to mass times acceleration. Now we have the force applied, which is this, or the parallel force, right? And we have the mass. So let's just solve for this. So our force applied, let's just substitute our values. So the force applied will be 248.5 newtons equals to mass of 60 kilograms times the acceleration. We solve for the acceleration, so we get 248.5 divided by 60. So our acceleration is equal to, you plug it in the calculator and you get 4.14 meters per second square. Alright, so that's our answer for part A of this problem.